All right, hi everybody. This is the 7th video of the series. What we're going to look at today is understanding logic operators and how to use logic operators to do repetitions similar to for loops, but a different kind of loop today called a while loop, which is logic-based repetition. The other thing we're going to take a look at is if-else statements, where we get to make logic-based decisions or logic-based choices. So at the end of this video, I'd like you to understand logic-based operators, while loops, as well as if-else statements. So with that, let's get learning. All right, so let's talk a little bit about logic. So if we take a look at logic in the context of a computer program, what we're really talking about is whether a computer can determine if something is true or false. So taking a look at this, let's just do a couple of very simple examples. So if I told you 3 is greater than 4, true or false, you would automatically, I hope, say 3 is not greater than 4. Therefore, that statement is false. And the computer will also say that if we write 3 greater than symbol 4. And when the computer says false, what it actually hands back is a value of 0 that's illogical. So it's going to say 0 represents false and 1 represents true. So the second example I'm going to ask is this one here, which is 3 equal to 3? So this equal sign in MATLAB basically says, is 3 equal to 3? So this is true, and therefore MATLAB will output for this operation a value of 1. This next line here talks about is 3 not equal to 4? So this squiggle line here represents not equal to. So not equal to 4 basically means that 3 is equal to 3, so 3 cannot be equal to 4, and therefore this is true, right? So 3 is not equal to 4, and MATLAB will hand back a value of 1 to us. And then the last example we're going to talk about for logic operators, at least this round, is going to be, is 3 not equal to 3? Well, 3 is equal to 3, so it can't be not equal to 3, and therefore this statement will be false, and MATLAB will hand back a value of 0. So at this point, we can take a look and see if this is actually true in MATLAB. So let's go into MATLAB and take a quick look at these logical operators. So here we are in MATLAB, and I'm just going to use the command screen because I'm going to come back to this other program in a second. So the first one we said was 3 greater than 4. We hit enter, and we can see that MATLAB hands back an answer that is actually of the type logical, and the logical response is 0. So the second one that we took a look at was 3 equals to 3, and that one we said was true, and what we should see is a value of 1 that's also a logical, right? So logical value 1 means true. The next one we had was 3 not equal to 4. Remember, this one was true, right? So we had a value of 1 come back. It's again a logical. And then 3 not equal to 3 was our final example, which was false. And we see we get a value of 0. So that is our definitions of logicals. So what I'd like to do next is actually try and use what is called a while statement to perform the example problem from last time, which is count to 10 in increments of 2. So go 0, 2, 4, 6, 8, 10. The program we wrote last time used a for loop, which meant that we were going to repeat this process here inside of this for statement. We're going to repeat it for 6 times. So we're going to repeat it from 1 to 6 times. So 1, 2, 3, 4, 5, 6. Right? So 6 loops. What I'd like to do is see if we can do this with logic instead of actually specifying the number of times we have to repeat this. So let's take a look and see if we can do that. So here is the logic version of repetition. So the logic version of repetition says the following. It says, while a certain thing is true, you're going to repeat the processes or the code inside of that while loop. So while something is holding true, we're going to repeat what's happening inside of that code. So let's see how this applies to our counting by 2 example. So this was the flowchart that we had last time, except I've made a small change to it. I'm going to have you take a look at this for a second and see if you can recognize the change that's been made to this flowchart. So hopefully you've had a chance to take a quick look at it. We start here, we introduce a value of I equals 0, so we set up an initial value I equals 0. Then we go into this decision triangle here, decision diamond, and what we can see is it says while I is less than or equal to 10, we're going to perform this loop. So while this is true, is it true? Yes. We're going to do this loop here. So what that means is I is going to start off at 0, then it's going to go to 2, 4, 6, 8, then 10. It's going to print all of those I values here. And then after it reaches 10, the next value is going to be 12, which is not less than 10. And it's going to leave that while loop and end the program. So hopefully, if we do this correctly, we're going to have the same outcome as a for loop, except this time, instead of specifying how many times we're going to loop, we specify the logic to end the loop. So we specify a logic statement that ends the loop. And that's how while repetition works. So let's go take a look in MATLAB and see if we can change that code from last time, which had the for loop, into a while loop, and see if we can get it to work according to counting from 0 to 10 in increments of 2. So here we are in MATLAB. And what I'm going to do is I'm going to come in here and I'm going to change the for loop here to a while loop. So repeat the process while, and in this case we're going to have to decide what the case or what the logic is. I is less than or equal to 10. Right? So that's the logic statement that we are going to use. So here we're going to say while I is less than or equal to 10, repeat this loop. As you can see, the two processes here that are repeated are exactly the same as they were before for the for loop. The only thing that's changed is the criteria for looping. So for a for loop, we required it repeated 6 times. For a while loop, we require it repeats until the value is greater than 10. So let's take a look and see what happens when we run this. So let's hit run. And what we can see is I has a value of 0 initially, goes to 2, 4, 6, 8, and then 10. When I is greater than 10 on that loop, right? So we do I plus 2 is equal to 12. This statement is no longer true, and therefore it does not perform these 2 lines of computation again. It automatically moves on to the next line of computation. So this is really useful when you're trying to accomplish something that reaches a certain logic. So while a number is bigger than a certain number, while a number is smaller than a certain number, these are examples of places where while loops can be really useful. And one really great example in numerics is while the error of a given calculation is bigger than a certain number, you're going to repeat the calculation until the error is smaller than your desired number. And if you do numerical programming, you're going to see that type of a while loop occur very frequently in the types of programming you do. So with that said, we're going to return to the presentation mode, and take a look at if statements next. So let's go back and take a look. So here, what I'm going to just quickly talk about is a if statement. So this is not repetition anymore. This is a decision statement. So we're going to use logic now to make decisions. So in MATLAB or in a program, we might come to a point where we want to make a decision between two options. And we'll do an example here in a second. But the decision is going to be made based on whether something is true or something is false. So if something is true, what's going to happen is we're going to do this process. If this logic term is false, we're going to do the alternative process. So in other words, if a process is true, we run this, else we run a secondary process. So an example of this is if we are going too fast, that is true, the code here might be to slow down. If on the other hand, we are, say, if we are going too fast is false, right? So we're going too slow, the command here might be to speed up, right? So this could be a very primitive form of making decisions based on the current criteria, whether it's true or false. So this if statement is basically saying, if you have a certain thing that's true, do this, else if it's not true, do this, right? Pretty straightforward. So the example that we're going to try today is what's called a coin toss problem. So we're going to create a numerical coin tosser, right? So what I would like to do is essentially try and determine if a computer can give us heads or tails in a random sense, just like flipping a coin. So the way that we're going to do this is we're going to use logic, right? So we're going to start our program, and the first thing we're going to do is create a random number x between 0 and 1. So if we create a random number x between 0 and 1, we can say if x is greater than 0.5, if that's true, we're going to call it a heads. And if x is not greater than 0.5, so it's less than or equal to 0.5, it's going to be false, and therefore we will give it a value of tails. So here is our if statement, and what you can see is we've created a decision here, and a decision is a diamond because we have a input coming in, which is the value of x, and we say if x is greater than 0.5, there's a true leg here, or a true vertex, and then there's a false vertex on this side over here. So the diamond here represents something coming in and two options going out that you have to choose between. So let's take a quick look and see how this codes up in MATLAB in a moment. So going back to our if statement here, we have x equals rand 0.1, this is the MATLAB code. If x is greater than 0.5, we're going to display heads. Else, we're going to display tails. So if it's not greater than 0.5, we're going to display tails. So what I'm going to suggest is why don't you go and try this out as a retrieval practice, pause the video, and then I will join you after you've given it a try. Okay, welcome back. And here we are in MATLAB. So I'm just going to quickly clear my command window, and we're going to go in and we're going to write this code for the if-else statement for a coin toss. So I'm just going to put up here a comment which says coin toss example, like this. And what we're going to start off with is the inputs to the problem, right? So the inputs are going to be x equals a random number, and a random number of size 1 is simply a single random number. So if we look at this 0.81, that's greater than 0.5, it would be a heads. Also a heads. now a tails, now a heads, now a heads, now a tails. All right, so we're going to now make a decision. I'm going to call it a logical decision here using an if statement. And this is, remember, that triangle. So we're going to put in the x value and we're going to make a decision whether it's a heads gets printed or a tails get printed. So I'm going to say if x is greater than 0.5, so there's my logic statement, right? If that statement is true, and I can put it like this, then I'm going to say display. That's a new command. It's another way of displaying something. So display tails, else display, oops, I got that wrong. It would be heads. There we go. And else tails, right? So we said if it's lower than 0.5, we would be tails. If it's greater than 0.5, it's heads. So let me hit end now here. So an if statement is comprised of if something is true, this process, else if it's not true, this process, and then we have to tell MATLAB where this ends. All right, so at this point I'm going to hit run. I'm going to call this coin toss example, and what we should see is when we run this, the coin toss example gives tails. The next time we run it, it gives heads, 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 tails. It's pretty random. It's a good sign, right? So we see here every time we run this, we get either a heads or a tails, depending on what the value of x is, right? So I could also display the value of x like this. And then let's display x for the other one down here. And hopefully this works, so we can see what is the value of x when we get a heads or a tail. So 0.84, that's x, right? So that's a heads, heads, heads. Oh boy, racking up the heads here. Okay, tails, right? Because it's below 0.5. Heads, tails, heads, tails, tails, tails. So this looks like quite an interesting coin toss program we've created. So this example here hopefully tells you a little bit about an if-else statement. So if something is true, do something. If it's not true, do something else. This is really useful for any point in a code or a program where you need to make a decision. So it's a logic-based decision-making process. All right, so let's return to our final conclusion and talk about the end. So here we are. This is the goals of today. We had the following outcomes: understand logic operators. So hopefully you remember the logic operators: greater than, equal is equal to, tilde equal is not equal to, less than. There's other logic operators which you can get into. So you can get into ands and ors as part of logic. That will be coming in a later video. We talked a little bit about repetition based on logic, which is a while statement. So you have a statement called while. Something is true. Repeat the things that are inside that while loop, right? It's different than a for loop because a for loop says for this classification or for this many times, repeat what's inside of this for loop. This one basically says while something is true, do this. And then the other thing we talked about today was decisions based on logic. So if something is true, do this. If something is not true, do this. There's more complicated structures for if statements as well. So you can get into if, else if, else if, else, and as well. That will come in a later video as well. I just want to keep things a little bit simpler right now so that you feel confident and comfortable moving forward. So as you do this, don't forget that there's some practice problems in the description of this video, and go give those a try. Really try and understand it, retrieve this information back, practice it in code, and really strengthen your understanding of this. All right, until next time, good luck programming, take care, and do a great job with MATLAB.